not looking at the geometry of the situation, not using isoclines, but having some technique to actually solve analytically a differential equation. So I think so far, here's what we've done. It's not a lot, you guys. Number one, and by the way, I'm only looking at first order. We've looked at a separable differential equation, and a separable differential equation is merely an equation that can be expressed in the following form. That y prime is equal to something that can be expressed as a product of two functions. One solely in x, one solely in y. However, last time you met, I think, you guys tell me if I'm wrong, I merely gave you an introduction to linear. First order DEs. That is to say, a differential equation that can be expressed in the form y plus some function solely in x times y, being equal to some function solely in x. I'll call it q of x. Uh-oh. I miswrote. I meant y prime. But you guys, it's been a long week, and I didn't write anything down. Is it not true that I only looked at one simple example? Good. Yeah. I was hoping so. Well, I shouldn't say it that way. That's what I remember. So if you don't mind, I'm going to clear this mess and take a peek at some more examples. So if I asked you guys to consider this differential equation, you guys, I just want a yes or no response. So, question. Is that already expressed in standard form for a first order linear DE? Yes. Yeah, I think it is. It's just that to solve a first order linear DE, when it's in this form, I jump in and I consider for myself an integrating factor. And the integrating factor for a first order linear DE is going to look just like this. It's going to be nothing more than e raised to power. That's the integral of my p of x with respect to x. And you guys, I'm a mathematician. If you want me to re-justify why the heck I ought to do next is going to work, please, I'll be glad to justify anything you want. I maintain that with a first order linear DE in this form, if I multiply both sides by an integrating factor, something really nice happens on the left-hand side. So let's identify what that integrating factor is. I think in this example, it's just going to be e to the power of the integral of 5 with respect to x. It's just that if I multiply both sides of this equation by e to the 5x, here's what I get. On the left-hand side, what I generate ends up being nothing more than the derivative with respect to x of the product of my integrating factor with my dependent variable y. But listen to what I said carefully. I'm saying multiplying both sides by the integrating factor. And again, you're paying money to be here. Don't be embarrassed in asking why. If you want me to repeat that process from last time, I'd be very happy to.
Why is it to the integral of 5 dx and not 50 dx?
Because I'm identifying the p of x as being the coefficient of y, as opposed to q of x. Okay. Yes, sir.
So where are we using the integrating factor to get the thing in parentheses? Are we dividing or multiplying?
Multiplying, sir. I'm intentionally skipping a step. Let me come back one step. I'm going to rewrite what I have on the board. I'm not changing it. But I need to impress upon you why this works so beautifully.
And why is it no longer dy over dx?
Absolutely not. I'm saying the result of differentiating with respect to this product gives you the left-hand side times the integrating factor. So Bradley, let me justify that. I'll put an extra step. You guys, check out what happens when I take e to the 5x and I multiply both sides by it. Here's what I get.
And what about the constant?
Which constant?
When you integrated e to the integral of 5 times the integral of dx, how come there's no constant? How come it's not e to the 5x plus c?
Oh, gotcha. Just skip that question. I'll come back to it in a second.
Okay.
So you guys know tricks. Do you not agree that from here to here, all that really does is I multiply both sides by the integrating factor? Nothing more. But take a break. Would you also not agree that if I were to take one step backwards down here and differentiate this product, it is a product of two functions in x because y is a dependent variable. Here's what I get. I get the first. Oh, there it is. Times the second as it don't touch. Oh, there it is. Plus the first as is this time don't touch. Times the root of the second, but that's just sitting over here. And so that's the beauty behind this technique. I just think what you see on the left-hand side is a result of differentiating with respect to x, that product. Now, I know when I came to class, I didn't say it this way. When I came into class last week, I actually derived what the solution looks like in the general setting, whereas here I'm justifying it with a particular integrating factor and a particular dE that happens to be in that form. Whereas it's much more general when I derived this in class last time. But now do you guys agree that this really is just drew what's inside the parentheses? Now I think if my job really is to solve for y in terms of x, my gosh, you guys, I better start de-shelling from outside in. Y is not isolated because may is being multiplied by garbage, but outside of that, I think the outermost shell is going to differentiate with respect to x some stuff. So why not undo the differentiation process? I'll undo the differentiation process with respect to x on both sides of the equal sign. On the left-hand side, I think I get this times the integrating factor, which is e to the 5x. Oh, you guys, I got to slow down, because now to undo the differentiation process on the left-hand side, I missed it, sorry. To undo the differentiation process on the right-hand side, I actually got to dive in integral terms. Do you guys agree? Oh, but that's still a piece of cake, isn't it? That just simply tells me that y e to the 5x is equal to, yikes, I'm sorry I'm so slow. Is that a 10? E to the 5x? Plus. Does it really matter? Yes. I think it matters a lot. I have no way the ability to just ignore that constant integration. Here's why. Because when I isolate my dependent variable, dividing both sides by e to the 5x affects greatly that constancy. So I think I'm left with y as a function in x being equal to, is that a 10? Plus c times e to the 5x. I misspoke. E to the negative 5x. Notice how my constant integration is no longer just a mere constant. It's actually a factor in the second term. Are you there? Okay. Yes, sir.
So e to the negative 5x comes from dividing e to the 5x.
On both sides, or if you don't like the way of saying that in English, say this. Bless you. We'll multiply both sides by e to the negative 5x to get rid of it. Same thing. So Brad, check this out. Because you asked a question. Why the heck am I not considering constant integration?
Yes.
Let's pretend I did. So I think there's a plus c up here.
Yeah.
Can I do it in red so you can see I'm changing things? Isn't it the same thing as this?
Yes.
But now when I multiply both sides by that red beast, now both sides have a common factor of a, which is non-zero. Divide both sides by it, it's gone. Do you see why I'm considering n integrating factor? I'm using that keyword, that indefinite article in English, n. Meaning just one of them. Doesn't matter what it is. Because if you consider one for which a is not equal to 1, no big deal. Divide both sides by it. Okay. So I do have the right to suppress that constant integration.
So where you got the derivative there and that we integrate from, are we just supposed to kind of just see that?
You mean from here to here?
Yes. Are we
Yes.
just supposed to see that that's the derivative?
I hate, no, I want to take those words back. I hate to say I want you to see it.
Yeah.
It's just in class I derived it out of thin air.
Okay.
And since I derived it in class last time, or even maybe justified with this particular example this time, I'm just saying from now on you've got the right to proclaim that if you were to multiply both sides by the integrating factor, you really would get the derivative with respect to x of the product of the dependent variable in the integrating factor. Because because I proved it in a general setting. Once I prove something in a general setting, you guys get to fly with it. Make sense?
Yeah, kind of.
All right. How about something different?
Okay.
Oh, I don't know what this is going to look like. I might need the room. I better erase this. So you guys have changed the game a little bit, maybe with the second example. Unlike the first, I gave you some initial value conditions so that we can solve for the unknown constant c. Secondly, just to make this legal and for things to be continuous, I was just restricting x to be here so I wouldn't have to worry about dealing with the vertical tangent lines for that graph. That's really the only reason. So let's see if you and I can't solve this in the same darn way. Take a peek. I think this is my standard form for first order linear, where p of x is tangent of x, q of x is merely cosine squared of x. So to solve this dE, apply this new technique. I'll identify what that integrating factor is, and the integrating factor as a function solely of x ends up being e to this power. Oh, you guys are losing your deep sleep. Or very nice. Does it agree? Yes.
Do you need to put the absolute value around that because it comes up with natural log?
Ah, who bothers? Got a nice restriction. Everything's positive. And I think in multiplying both sides by the integrating factor, let's see if you guys can crank this out. If I were to multiply, I'm too lazy to do it, but if I were to multiply both sides by the integrating factor on the left-hand side, what I generate is a multi-termed expression, which is nothing more than the result of differentiating with respect to x a product of what with what? The integrating factor. And my dependent variable. It's just that what I end up on the right-hand side with is yet again the product of my integrating factor and what's sitting over there. But jeepers, that's just cosine. Come on, you guys be honest. Is that okay?
I just don't see how you got to see it.
I skipped too many steps. I was simply suggesting this, that I got e to the integral of sine of x over cosine of x with respect to x, and I was simply committing to this. So I think that gives me this. I think that gives me this. And if I were to back substitute, I think it gives me this. But since I'm allowing x only to be between 0 and pi halves, I think I've got the right to proclaim this. In other words, absolute value bars is superfluous. But I think I'd like to cancel e and natural log functions by composition. Oh shoot, I can't. Darn it. There's a factor of -1 in the way. I'll get rid of it. But that's just simply this. Ah, but now there's nothing in between my natural exponential function, my natural logarithmic function. So I do indeed get to cancel by a composition. Okay, so I skipped a few steps. Is that okay? And if it is okay, and the rest is okay, then cheapers. Now I just get to undo the differentiation process. And I maintain the secant of x times my y is nothing more than the integral of the cosine of x with respect to x. Oh, shoot. That too's a piece of cake, you guys, isn't it? So I have this. Is that sine of x? Oh, but we can isolate y in this equation, can't we? So So y as a function in x is nothing more than the product of the sine of x with the cosine of x plus c times the cosine of x. I might even in English refer to this as my general solution. I like that adjective general because for various different constant c, there's implemented choices, I've got a different particular solution. Now I maintain with some initial value addition, I might be able to find a particular solution by solving for that constant c. You guys, I'm sorry for my notation. Now that I look at it, it looks horrible, c times cosine of x. But c, the first c is just a constant, right? I should have chosen a different letter. But I maintain with that initial value condition, you guys, I can do this. Let's give it a shot. So, with my y of help me, is it pi quarters equals root 2? That means when I plug root 2 in for y, I get to corresponding plug pi quarters in for x.
2 over 2. Plus c times root 2.
Does that give me this? Or shall I say this?
Why don't you just combine the c and the root 2 over 2 into another constant?
That would work just as well. I think that gives me this.
You can simplify that even further. You can multiply the c or the 2 by both sides and create a new constant.
Oh, you're right, but if I
You
do
could
that,
s-
I'll have to replace this with 1/2 of it, and then 1/2
Okay.
of it come right back in. You're right, I could do that. Right?
Okay.
So everybody, I'm running out of room, I'm sorry, but how about in green? I guess what I'm really trying to suggest is that my particular solution is going to involve one being equal to the product of these two pieces, plus my c times the cosine of x. There's my particular solution with that initial value condition. Come on, you guys, where are you in the level of happiness?
Happy?
Good. Yeah, I think it should be easy. I think the only things, I'm not done with my examples, but I think the only thing I've done that's sophisticated is driving that, if you multiply both sides by that piece, you get what I have nice over there on the bottom. Still not easy. You guys, this is just a very, very bad pen day. Is it decent, Chris? Oh, awesome, thank you very much. Oh, you guys, do I have anything else that's kind of interesting? Yes, no? What?
That's not the form of the linear.
Oh, you're right. So I guess if I treat this as a 1 over x times y, my p of x really just 1, isn't it? 1 over x. Does that fix my mistake? Yeah, I still don't think it fixes my mistake. Technically speaking, that p of x y term has got to be on the left-hand side of the equal sign, and trust me, those negative signs will make the answer change dramatically. So I made 2 mistakes. Let me fix them. I think first rewriting this dE in standard form, it looks like a y prime minus 1 over x times y being equal to the natural log of x. This time you guys know tricks. Do you see how my p of x is negative 1 over x, not positive 1 over x? And my q of x is clearly the natural log of x. So, if I now consider my integrating factor and work correctly, I think it becomes e to the interval of 1 over x with respect to x. I just gotta change the signs on the outside. But in the end, isn't that just something you're gonna do? By the way, in this example, I really do have the mathematical legal right to suppress the absolute value bars, because take a peek at that Q of X function. It's already defined only for strictly positive real numbers. So I know I've got that understood restriction. And you guys, I think I made a mistake. Yeah, I didn't mean this mistake to happen. This really was my mistake. Sorry. Can you correct me? Thank you. I agree completely. My apologies. And now in multiplying both sides by that integrating factor, I just maintain. Again, I sound like a broken record, since I've already proven it. The left-hand side, upon multiplying it by that thing, ends up being the result of differentiating with respect to x. My integrating factor times my dependent variable. But again, just keep in mind, you guys, I'm saying in English, I'm multiplying both sides in their entirety by 1 over x. Which means when I undo the differentiation process, you guys, I'm just being honest, isn't life a piece of cake? Because I think in our heads, we can anti-differentiate natural log of x over x. I said in our heads, we really can do this. I trust you with it.
Set u equal to the natural.
One hand. Yeah, I agree, Brad.
Okay.
Oh, plus c. Now I'm solving for y in terms of x. I guess y is a function and x is simply, is that a 1/2? X natural log square root of x plus cx. You guys, do you mind just to clean things up a little bit? Do you mind? Just to make it look nicer. I mean, call constants whatever they are.
It's not a constant.
But how does that
It's not
work?
legal.
Well, x isn't a constant.
Well, you can.
You guys, no, you guys are 100% correct. I can't do this.
Oh.
Because really, it's not a constant. I don't know what x is. And so I absorb it into constant, then for different values of x and a value of my function, I won't be able to value the corresponding y values. Do you see my point? So don't ever commit this horrible, grave mathematical sin of referring to an algebraic expression as a constant. You never want to do that. You won't be able to value your final solution at various different values. All right, my mistake. I meant to just stop there. Man, you guys, I'm so disappointed. These are so easy.
That's okay.
Maybe this is better. I'll try one more. Just one more stab at this. See if I can come up with something more beady. What number is that? 3. 3? That's I think last one.
That'd be nice. Oh, if this were our quiz.
It is a T, yes.
I don't think I don't think he's gonna quiz us on this tomorrow. That's only what we did up to
How about just a
today.
quick yes or no? Standard form?
Yes.
Yes.
Piece of cake then. Let's you and I just rattle off very quickly what the integrating factor is. Hold it here. So my integrating factor is a function in t is simply going to be e to this power. Isn't that just simply this? You know, you guys, maybe it's not. I got to backtrack for a minute. Can I make a stipulation? I should have written this. T is strictly bigger than -1. Just to make this legal, I can suppress the absolute value bars. And that being the case, I think to multiply both sides by the integrating factor, I hope I sound boring at this point. What you get on the left-hand side is a result of differentiating with respect to t, the product of your dependent variable with that integrating factor. In undoing the differentiation process, 1/3.
T plus 1.
T plus 1.
Which is 3rd. Plus c.
Yeah. And so in finally isolating t completely, excuse me, I misspoke. In isolating y completely, I think y as a function in t has this algebraicness as its corresponding algebra. So t plus 1 twice, plus some constant over t plus 1. Yes, sir. You know, I think, oh, my example's still on the board. Because I happen to have a negative coefficient up front. Okay. You guys, I don't have it printed out. All right, I'm gonna struggle. Let's see. I can't do this. All right, you guys, I'm in trouble. I failed. It's a long weekend, so please forgive me. I failed to bring in my thumb drive. Do you guys think because it takes so much typing, can I steal something just from my past? Sorry how embarrassing this might be, but at least this way I don't have to rewrite everything. So can I be a thief?
Where do you come up with these things?
You just make them up. Oh, Flatland Council. Now, you guys, I'm like you. I have to come back and read this from scratch. So here I go. The major water reservoir in the Republic of Flatland holds. You guys know what Flatland is, right? Supplies the city of Triglav with 1 million gallons a day. Let me draw a picture. And in my picture, here's my reservoir. And it's supplying the city of Triglav with 1 million gallons per day. Now the reservoir is partly refilled by a spring that provides 9/10 is 1 million gallons per day. And the rest, 1/10 million gallons a day, is run by or is provided by runoff from surrounding land. So another 1/10 million gallons per day. Now the spring might be clean, but the runoff contains salt with a concentration of 0.0001. Oh, what are my units, you guys? Pounds per gallon. And assume that there is no salt in the reservoir initially, and that the reservoir, if I can enunciate, is well mixed. Find the concentration of salt in the reservoir as a function of time. Do you guys, do you mind if we don't? Can I cheat and answer an easier question first? Instead of concentration, can I just find the amount of salt that I take? And once I find that, all I have to do is divide by the volume of the body of fluid, which is 100 million gallons. I got the concentration. So I'm just saying, maybe it's easier initially just to solve for the amount of salt the tank at time t instead. So let's give it a shot. I think my picture says a lot. Now, can you guys imagine there's this huge mathematical god with a big spoon stirring up the water here, because I need to make an assumption that the concentration of salt at any given spot in this particular tank is the same.
Or maybe there could just be a mixer in the tank.
Sounds more Greek the way I say it. Right? So everybody, I think the easiest thing to do is this: to build a differential equation involving the unknown amount of salt in the tank at time t. And guys, why don't we use letter A instead of Y? It may represent the amount of salt in the tank at time t. I think the easiest way to set up a differential equation mathematically modeling this problem situation is to talk about how the rate at which the amount of salt in the tank is changing with respect to time. I think it's easy for this reason. I think it's nothing more than the rate at which salt is coming in minus the rate at which salt is going out. You guys okay with my words in English? I'm talking about the rate at which the amount of salt is coming in, not water, the amount of salt. Now, personally, when I solve a DE, I tend to not want to put units in. I suppress them because it makes my life easy. But because I'm setting this up, can I put units in on the first step just to make sure I'm not making any mistakes? So I think dA dt is equal to, let's concentrate on the first term. Would you guys not agree that the rate at which the amount of fluid is coming into the tank is going to be 1/10 of a million gallon per day? Times the concentration of the salt in that particular amount of fluid, which is 10, 100,000. Is that one over 10,000? Is it pounds per day?
Yes.
No, it's pounds per gallon. Thank you. Plus, I misspoke, sorry. Minus the rate at which the salt is leaving the tank, and the rate of flow of fluid is going to be 1 million gallons per day. Times the concentration of salt, which I clearly labeled as, I can't read that far. The concentration was labeled as...
There's none, I don't think. Or going out.
Oh, you're
No.
right, there isn't any
Yeah,
concentration
there isn't
given.
any.
I can't, because I think this over time is changing. Because I think the concentration of salt in the body of water going out of the tank is the same as the concentration of salt in the tank anywhere if it really is indeed well mixed. Do you see my point? So let's do this instead. To talk about the concentration of salt in the tank at time t, why not just interpret it as what it should be? It's a ratio of the amount of salt in the tank at time t, which I think will be labeled as A, all over the amount of water that's in the tank, and I forget what it was.
100 kilograms.
Wasn't it changing?
It's filled.
No, I don't think it's changing at all. Think about it. As far as the water flow is concerned, 1 million gallons leave the tank per day, but I think, well, look at that. Some of these 2 weeks is 1 million gallons coming in. If you think I'm being too simplistic, don't worry about it. I assume my second example isn't too simplistic.
So,
Yes.
is there ever, because I mean we did this last semester too, is there ever going to be a situation where the amount going in is not equal to the amount going out?
Did I ask this question in Math 31 this summer?
You asked a bunch of these in Math 31, yeah.
Right,
We had social anarchists in Paraboland.
gosh, yeah. So life takes its turns and twists. So, Brad,
Yeah.
my second example, I'll mess
Yeah.
it all up.
Okay.
This summer in Math 31, when I talked about differential equations, I'm sure I did not go heavily into first order linear. I might not even mention first. That's why.
This is about as far as we got.
Because this will only
Yeah.
rely on separation of variables.
Okay.
Can we see the social anarchists in Paraboland question?
I got it.
Yes.
I
I want
can
to
bring
see
it in.
this.
Yes. Brad's got it.
Yeah, I can bring it
Okay,
in tomorrow.
show me.
All right.
Isn't it 100 million gallons being entered into the reservoir?
It's pretty good.
That's just so much. I guess my question is, why are you only using the 1/10 on the left side instead of the sum of 1/10?
Okay, I'll do it your way. I'll do it your way. I can add to this is it 9/10? Million gallons per day. Times the concentration of salt in that body of water, which is I was too lazy, I didn't put it in because it just drops out anyways. But if you want to put it in because it makes more sense, please, by all means do so. Oh, by the way, I forgot something, darn it, I forgot to divide out by the amount of water in there, which you guys agree doesn't change, it's just 100 million gallons. Do you guys agree? That being the case, you guys, it's getting kind of confusing. What cancels? Oh, here's what cancels. Where's my blue pen? Shoot, I couldn't see it. Whereas A is measured in pounds. So I guess my final units are pounds per day. Or at least with the second term. So I guess I get 100, excuse me, times A measured in pounds per day. However, on the left-hand side of the subtraction operation, now it cancels. Oh, you're right. Nothing cancels because these are measured gallons. This quantity is measured in millions of gallons. How am I going to fix that? You just change them. Can we do this one? So dA dt is equal to 1/10 million gallons per day times 1 pound. Let's change my denominator to million gallons. To change to million gallons, this quantity right here going to be 1 over 100. So I guess in the end, I do get some nifty little blue cancellation with my units. And I think in the end, I see that the rate at which A is changing with respect to time is going to be nothing more than, is that a 10 pounds per day minus 1/100th times A pounds per day. Oh, by the way, I think dA dt should clearly be measured in pounds per day. You guys, I might have made a mistake on the board. I might have, but at least my units make sense. So far, so good. I'm getting nervous. I'm running out of room. Can I write this one more time, just suppressing units? And if I were to write this one more time, suppressing units, wouldn't I just get dA dt? Equals, oh, I don't know, you guys, what looks nice? Would it be a 1/100th? Times 1,000 minus A. You guys, maybe here more than anything else today, can you please stop me if I'm writing something that's unclear? And, so,
The thought comes from,
so I was being lazy. I was just trying to pull out a factor of 1/100th for both terms.
Wouldn't you pull out the pounds per day too? Still?
No, I think I'll ignore them completely because this is
Okay.
measured in pounds per day. They cancel.
Okay.
Since I got the same units on both sides, now I'm going to suppress them. Personally, you guys, I would have suppressed them earlier. Again, it's my first example in class. I'm just being very careful with my units. Do you guys think I can subclass this DE as being separable?
Yes.
Oh, piece of cake. So let's just do that. Let's separate our variables. And I think that tells me that I don't have enough room. I don't want to erase my picture. You tell me if I'm being too condensed. Does that give me 1 over this, integrated with respect to A, being equal to a constant times the integral of 1 with respect to t? Now, life is a piece of cake. I think this just gives me the negative natural log of the absolute value